For nearly a century, physics has been staring at a deep, unbridgeable gap between its two greatest achievements. Today, we're diving into a proposal that claims to leap right over it. It's called Aramis field theory. And it's not just another theory. Its proponents claim it's a new universal law. The basic idea? Everything you see, everything you are, is just a different vibration of one single underlying field. And that brings us to the core question, right? What if all the things we think of as fundamental, particles, forces, even the fabric of space-time itself, aren't fundamental at all? What if they're all just emergent patterns, kind of like ripples appearing on the surface of one single incredibly deep ocean?
Now, to really get why this is so huge, you have to appreciate the problem it's trying to solve. Modern physics has two rulebooks: general relativity, which beautifully describes the big stuff, planets, galaxies, the smooth fabric of space-time, and quantum mechanics, which governs the bizarre, pixelated world of tiny particles. The problem? They totally contradict each other. When you try to use them together, like inside a black hole or at the Big Bang, the math just breaks. It's a fundamental crisis. So, for decades, the search has been on for a way to fix this. The solution that Aramis field theory puts on the table is about as radical as it gets: the one-field hypothesis.
The entire framework is built on this one entity, the Aramis field, which we'll just call A. Now, you have to get this. It's not a field in the universe. The theory says it is the universe. Every single thing we observe, from an electron to a distant star to the very force of gravity holding you in your seat, it's all just a different resonance, a different note being played on this one single cosmic field.
And if that's true, well, it reframes literally everything. Look at these core postulates. Space-time isn't the background stage anymore. It's an emergent property. Gravity isn't the warping of space. It's a frequency gradient in the field. And here's the biggest one. The whole standard model of particle physics, our best catalog of reality's building blocks, isn't a set of fundamental assumptions. No, it's a consequence that just naturally arises from the field's internal logic.
Okay, so those are some incredibly bold claims. How does the theory actually back them up? Well, it's not just philosophy. It all boils down to a single, rigorous mathematical structure, a master equation that supposedly gives birth to all of known physics.
And this is it, the unified field Lagrangian. Now, a Lagrangian is basically a compact formula that tells you how a system will evolve. And according to this framework, this incredibly simple-looking line describes the dynamics of the entire universe. What's so groundbreaking here is that this is proposed as an observational level mechanics. It doesn't need a pre-existing grid of space-time to function. It creates it.
So let's just break this down real quick. It has two main parts. The first bit, the kinetic term, that just governs motion, how waves and disturbances travel through the field. But the real secret sauce is in that second part, the potential term, V of A. You can think of it as defining an energy landscape for the field. It creates these stable valleys of low energy where the field prefers to settle. And those stable, self-sustaining resonant states, yeah, that's what we perceive as particles. And here's where it gets even more unique. According to the theory, embedded deep within that potential term, V of A, is a very special number, the golden ratio. This isn't just an accident. It's claimed to be a fundamental constant of nature that acts as a regulator, ensuring that when structures like particles emerge from the field, they do so in a way that is harmonically stable and self-similar across all scales. It's like the universe has a built-in tuning fork. Okay, so with that master equation in our back pocket, let's really unpack what this means for reality itself. Because this isn't just a minor update. It's like proposing a completely new operating system for the cosmos. This chart really lays out the paradigm shift. In standard physics, you've got space-time as a fundamental backdrop. Here, it's just a large-scale property of the field's resonance. Particles aren't little dots. They're more like stable, localized spirals or knots of tension in the field. And gravity, it's not the bending of space anymore. It's much more like a pressure gradient, a large-scale change in the field's frequency from one point to another. The best analogy here actually comes from stuff we already know, like phonons in a crystal. A phonon is a vibration that travels through a crystal lattice, and it behaves exactly like a particle. But it isn't a separate thing, it's just a collective behavior of the crystal. This theory is saying that's true for everything. Electrons, quarks, photons, they're all just phonons in the Aramis field. And that's why our existing physics are described as just linear projections, like flat, simplified maps of a much deeper, fundamentally hyperbolic reality.
So, as you can see, the ambition here goes way beyond just unifying physics. The claim is that this provides a new blueprint for reality itself. It's not trying to be a theory of everything, so much as it's trying to be the foundational, universal law from which everything emerges.
This quote right here really is the core of it all. Just think about this for a second. It's saying the Standard Model, our entire catalog of fundamental particles and forces, isn't something you have to plug into the theory as an assumption. It's something that drops out as an inevitable mathematical consequence of the field's basic wave structure. It's not an input, it's an output. So the big takeaway here is a totally new way to look at the universe. It's not a machine made of separate little parts anymore. It's more like a grand symphony of resonance, and spirals, and emergence, all playing out in a single unified field. It replaces a mechanical universe with a musical one, which, you have to admit, leaves us with a pretty profound question to think about.